this podcast, I'm going to talk about regression analysis. So this is the second time I've discussed it. The topics are going to be understanding relationships, trending and prediction. That's why we do regression analysis. I'm going to introduce the idea of R, or the Pearson R squared, independent variables, and dependent variables. R is equal to Pearson correlation coefficient. It's a common thing to calculate in statistics and quantitative analysis. In your book, there's all these really complex formulas. So if R is equal to -1, we call that a perfect inverse relationship or a perfect negative relationship. If R is equal to +1, we call that a perfect direct relationship or a perfect positive relationship. So when you see R, think relationship. R is equal to 1, it's a perfect relationship. If R is equal to 0, there's no relationship at all. And if R is equal to -1, there's a negative relationship. R moves from -1 to 1. That's the range of R. So what is R squared? How much of the change in Y can be explained by the change in X? When X changes, Y changes, and we try to measure what R squared is by how much. R is more or less different from R squared in the sense that it measures the relationship. R squared tries to measure the intensity. R squared, simply by squaring R, and it moves from 0 to 1. So let's look at pain medication and pain. The independent variable would be pain medication. We're going to manipulate pain medication to see how it impacts pain. So the dependent variable is pain. Let's hope that the relationship looks something like this. In this case, we'll say R is equal to -0.80, or R squared is equal to 0.64. R squared is simply by squaring R. In this case, we would say that, roughly saying, when we modify or manipulate pain medication, 64% of the change in pain can be attributed by the change in pain medication. Education and income. Education is the independent variable. The dependent variable is income. So let's say in this case, R is equal to +0.40. So education explains, there's a relationship between income and education. But R squared says that 16% or 0.16% of a change in income can be explained by education. So R shows there is a positive relationship. R squared shows the intensity that says how strong is that relationship. We also sometimes are forced to do multiple models to make sure that our regression analysis fits better. In this case, I have hair loss and age. But I may want to say, I want to look at hair loss under the age of 20. I want to look at hair loss between 20 and 30. I want to look at hair loss between 30 and 40. And then I want to look at hair loss above the age of 40. The reason I would do multiple models and develop several regression models would be to better understand the relationship. In this case, it's clear that hair loss is more pronounced in men as they get older. That makes sense to you. So the topics I discussed today were the R, or the Pearson R squared, independent variables, and dependent variables. And that's it for regression analysis.